You've been told a lie. You were told that nothing, absolutely nothing, can travel faster than light. But right now, on your screen, I'm moving a dot across the surface of the moon at 20 times the speed of light. Relax. Albert Einstein isn't rolling in his grave. He's actually laughing, because the famous universal speed limit has a massive loophole. Today, we're going to break the most famous rule in science. I'll show you 3 ways the universe appears to beat the speed of light without breaking the laws of physics. And at the end, I'll show you a real blueprint for a warp drive that makes Star Trek look less like science fiction and more like a homework problem. First, we need to respect the wall. As you accelerate, you gain energy. And Einstein showed us that energy and mass are 2 sides of the same coin. The faster you go, the heavier you become. As you approach the speed of light, your effective mass skyrockets toward infinity. To reach exactly light speed, you'd need more energy than exists in the entire universe. You don't hit a wall of steel, you hit it because of pure math. But here's the loophole. That wall only exists in a perfect vacuum. Inside materials like water or glass, light slows down. And when that happens, something incredible is allowed. In nuclear reactors, particles can move faster than light does inside that medium. Not faster than light in a vacuum, but faster than light that's been slowed down by matter. When that happens, space flashes with an eerie blue glow called Cherenkov Radiation. It's the optical version of a sonic boom. We've been beating light in laboratories for decades. But that's just particles. What about entire galaxies? And now, hold on to this idea. Because in just a few minutes, I'm going to show you why real NASA scientists actually sat down and calculated whether we could warp space-time itself. It turns out you don't need to outrun light if you can just move the floor underneath you. Einstein's rule says nothing can move through space faster than light. But space itself? It has no speed limit. During the Big Bang, space expanded so violently that distant points moved apart at trillions of times the speed of light. Even today, the edge of our observable universe is receding from us faster than light can ever reach. We're not losing those galaxies because they're flying away. We're losing them because the road between us is stretching faster than any signal can cross it. The galaxies aren't moving through space. Space itself is doing the moving. This doesn't break relativity. It's relativity working exactly as designed. So why can't we use this to send messages instantly? Let's look at that laser dot again. The dot moves at 20 times the speed of light, but it isn't a thing. It's an illusion. Each individual photon still travels at light speed. They just hit different spots at different times. It's like a stadium wave. The wave moves fast, but no single person runs around the stadium. You can't ride the wave to send a message. And that's the real law of the universe. Not speed, causality. You cannot move information faster than light. Or can you? This is the Alcubierre warp drive. It doesn't break Einstein's laws, it uses them against themselves. Instead of pushing a ship through space, it reshapes space-time. Space in front of the ship contracts, space behind it expands. The ship sits perfectly still inside a flat bubble, but the bubble itself moves. From the outside, that bubble can travel faster than light, while everything inside obeys relativity perfectly. The math works. The physics doesn't forbid it. The problem is the fuel. It requires something called negative energy, a substance we've only seen in tiny quantum effects. For now, warp drives remain theoretical, but the fact that the equations even allow it tells us something profound. We used to think the speed of light was the ultimate ceiling.
Now we know it's just a rule about how information flows. And everything we learned today started with something as simple as a laser dot on the moon.